Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in 8051 microcontroller. We're going to see timers and counter operation in 8051. In this video we're going to see the basic concepts about timer and counters, and we're going to see how to configure TCON and TMOD registers, right? And before going to this video, I would like to set up a clear expectation about timers and counters. To program timers and counters, you have to know in depth about the operation about the timer, how the timer works, when the timer will work as a counter, right? How to configure TMOD register, how to configure TCON register, what is interrupt, all those things you have to go through, right? So we'll see one by one, and today's video we're going to see just only the basics about timers and counters. We're going to see how the timer works and when it will work as a counter, right? So first we will see in 8051 we already know that it is an 8-bit controller, but it has two 16-bit registers, right? That is, it has two timers. One is timer 0 and timer 1. Timer 0 and timer 1, and both are 16-bit registers, right? And we have already seen the features about 8051 in previous videos, the architecture of 8051, right? I would request you to people to go through those videos and come back to those videos so that you can understand why we say timer as a 16-bit register, why is that we are splitting it as 8-bit here, all those concepts, okay? So timer 0 and timer 1 are the two important registers, timer registers in 8051, right? And you can understand that since it is an 8-bit controller, it is an 8051 is an 8-bit controller, this 16-bit timers will be segregated into two, that is lower 8 bits and higher 8 bits, lower 8 bits and higher 8 bits. We will see all those things, right? As of now you understand you have two timers which is of 16 bits, but both is being split as 8 bits, right? That is timer 0 you'll have lower 8 bits and higher 8 bits. Similarly timer 1 you'll have lower 8 bits and timer 8 bits. Sorry, higher 8 bits, right? And when we say timer, right, you got to understand that in 8051 timer will work as a timer and also it will work as a counter. This is very basic, right? When it will work as a timer and when it will work as a counter, right? Whenever we give input as a clock cycle, that is whenever it uses the crystal oscillator, we know that in 8051 we have a crystal oscillator, right? So if 8051 uses the clock cycle, the internal clock cycle, then it will work as a timer, right? So when it is working as a timer, it will generate a time delay, right? It will count the number of clock cycles inside the 8051, right? And when it will work as a counter, whenever we give an external clock pulse, not internal, external clock pulse, then the timer will work as a counter. What it will do is it will count the events happening outside the microcontroller, right? So when it will work as a timer, it will work as a timer when it uses the internal clock cycle, and when it uses the external clock cycle, then it will work as a counter, right? And as I said, you have two timers, that is timer 0 and timer 1, and both will be split as lower bits and higher bits. You can see that timer 0 will be represented as 0 and timer 1 will be represented as 1, right? This TL0 represents the lower order 8 bits of timer 0, and TH0 is nothing but higher order bytes of timer 0, right? And similarly TL1 represents the lower bits of timer 1, and TH1 represents the higher bits of timer 1, right? So the complete 16 bits is been split into lower bytes and higher bytes, 8 bits, correct? And now you understand that this, for the timer operation, right, each timer 0 and timer 1 will have its own registers. That is, it has two registers. One is TMOD register, and there is one common register which is called as TCON register. You will see that in depth, but as of now you understand that TMOD register, right? This TMOD register is also 8 bits. In that 8 bit, the lower order bits will be timer 0, right? And the higher order 4 bits will be timer 1, right? The lower order 4 bits will be timer 0 and this one will be timer 1, right? And you want to understand here what is TMOD register and what is TCON register, right? We know that we have timer 0 and timer 1, right? If you want to configure which timer that is used for the operation, right? That is either we are using timer 0 or timer 1, right? We have to control the timing and control operation. That will be taken care by this TCON register, right? And which mode it works, either it works in mode 1, mode 2, mode 3. In order to change different modes, in order to configure modes of operation of timer, then TMOD register is used. I repeat that, you have TMOD and TCON register, right? So both things, both the register timer 0 and timer 1 will access this TMOD and TCON register, which means in TMOD you will have lower 4 bits used by timer 0 and upper 4 bits used by the timer 1. And TCON register is used to control the timing operation, which means it will tell you which timer is used, timer 0 or timer 1, which overflow happens, whether it timer overflow, timer 1 overflows or timer 0 overflows. Like that, it will use the control operation of the timers, right? And when it comes to TMOD, we can able to select different modes where the timer works, right? That is about TMOD and TCON registers, right? I'll just explain all this M0, M1, M2 in successive slides, right? So now you understand what is timer and what are the different modes it works, right? As I said, it works in 2 modes. One is timer mode and counter mode. When it works timer mode, it works whenever the clock cycle is internal, it works in timer mode. And whenever it works, it uses the external clock cycle, it uses the counter mode, right? And when it uses the internal clock cycle, right, then it will count the internal machine cycle, right? And it can be calculated like whenever you can see here the internal machine cycles are counted, right? And whenever the clock frequency which is used is 12 megahertz, then the timer register is incremented in each and every milliseconds, right? And I would like to tell you one particular thing here. The timer registers, right? The timer register which we use will work as a up counter. Up counter. What is up counter? For every clock cycle, the count will increase, right? Either it is a internal clock cycle or external clock cycle. For every clock cycle, the counter will increase, right? And now you understand what is timer mode. Coming to counter mode, as I said, when we use external clock cycle, right? External clock cycle, then it will act as a counter mode, right? And here, each and every, in timer mode, there will be only one machine cycle that is needed, right? But here, for the every transition, that is, we are using external clock cycle. So every transition from 1 to 0, it will be considered as one cycle, right? So there should be a transition from 0 to 1 or 1 to 0, right? So in this mode, at least 2 machine cycles are needed, right? For every transitions. Right, in that case, when the frequency is 12 megahertz, right, the count frequency will be 12 divided by 24, which will be 500 kilohertz, right? So the counting here, the time duration is 2 microseconds, right? So as of now, you understand what is timer mode and what is counter mode, right? And now I'll just explain how the timer works as a timer mode and counter mode so that you can understand very clearly. Okay. So this is the very important diagram, right? As I said, we have different modes of operation, but this is the principal concept of timer mode and counter mode, right? So you know that we have a crystal oscillator, right? So the crystal oscillator frequency will be divided by 12 to determine the machine cycle, right? And here you can see that we have a switch, right? And we have counter input pin, right? Counter input pin, that is, I have said that in timer mode, whenever it uses the internal clock cycle, it works in timer mode, and whenever we use external clock cycle, it works as a counter mode, right? So look at this diagram, right? As if now you understand TR bit. TR bit is one important bit in TCON register, right? TR bit in TCON register. which tells you which timer operation is in operation, right? I already said what is TCON register. TCON register tells you that is, it controls the timing and timing operation. It tells you which timer is working, which overflow is happening, right? So this TR bit will be either TR0 or TR1, which is nothing but timer run bit, right? If you are using timer 0, it will be TR0. If you are using timer 1, it will be TR1, right? And we have something called gate bit, and also we have INTX pin, that is external interrupt pin. That is, it can be, we can give external interrupt by using these two pins, INT0 or INT1. These are the external interrupt, right? That is, whenever we use timer 0, it will be INT0, and if we are using timer 1, it will be INT1, right? Now I'll explain the core concept here, right? So now you can see we have a counter input pin, that is the external pin, external clock cycle, whenever we give external clock cycle, okay? So you can see here the switch connects to this particular pin, that is the internal clock cycle, that is internal crystal oscillator, right? So if it is combining here, then C by T is equal to 0, right? Which means in this mode, C by T, the timer or counter, right? So here it will be 0, which means it will work as a timer. That is what we say, whenever we use internal clock cycle, it will operate in a timer mode, right? When we give external clock pulse, right? When we give external clock pulse, you can see this is the external clock pulse. How this external clock pulse will be given? External clock pulse will be given either through this INT0 or INT1, right? So whenever the external clock pulse is given, then it will work like C by T is equal to 1, that is, it will work in the counter mode. Clear? Right. And now you can see here the timer starts. We know that it's TR0 or timer 1, right? It can be timer 0 or timer 1. The timer operation, the count will start only if this switch, you can see this switch is just to select whether it will work as a timer or counter. But only if this switch closes, right, the operation will start. That is, the timer counting will start, right? So this control will be done by these two gates. You can see AND gate and as well as an OR gate here, right? And you can see this particular pin, that is TR bit. TR bit is nothing but TR0 or TR1, right? Sir, what is TR0 and TR1? It's nothing but when we use timer 0, this will be timer 0, TR0, and if it is timer 1, then TR1, right? And only if it is enabled, if TR0 is enabled, either TR0 or either TR1 has to be enabled, right? So every time this bit will be 1, either TR0 or TR1 will be 1, right? Only then the timer will work, okay, right? And now if this switch has to be closed, then the output of this NAND gate, the AND gate, has to be 1, correct? So when it will be 1? When both the inputs has to be 1, right? Only if both the inputs is 1, then we will get the output as 1. Clear? Only if the output is 1, this switch will be closed. Correct? Right. Now, we know that this will be always 1. Either TR0 will be 1 or TR1 will be 1. Right? Now, we have to make this input as 1. Right? So, when that can be 1? You can see here we are using gate bit and we are using an internal. Right? Let me say that if the gate pin, right, if you are using gate, if the gate pin is 0, right, you can see there is a NOT gate here. If the gate bit input is 0, then obviously it will produce 1 here after this NOT gate. So if this is 1, irrespective of what value is this one, right, we don't want to worry about this int x pin, INTX pin. It can be 0 or 1, whatever may be, because it is an OR gate. So whatever that is combined with 1, it will automatically proceed with 1, right? So if this is 1, this input 1 will be there, and both the 1 will be there, and it will give 1. So this clock will be closed, the switch will be closed, and the counting operation will start. Clear? Right? So if gate bit is 0, right, by default this will be enabled, this will be 1, and the output of the AND gate will also be 1. Correct? Right. Say for example, if the gate bit is 1, right? What happens if gate bit is 1, then this will become 0, right? Then this will become 0. If this becomes 0, then definitely this pin, this output has to be 1, right? So definitely we need an external interrupt, right? That is, this pin has to be 1, right? Only if this is 1, what we can do is we can make this pin 1. Clear? If gate bit is 0, we don't want to worry about it. If gate bit is 1, then definitely we have to give an external interrupt. Whenever we give an external interrupt, what happens? It will work in a counter mode, right? So whenever we give the external interrupt, right, the external clock pulse, what happens? This INT0 or INT1 either has to be 1. This either INT0 we will use or INT1 we will use. So this will become 1, so that the output of this OR gate will be 1, and so that the AND gate output also will be 1. Clear? Right? So this is the normal operation of a timer, right? So this will work as a timer when we are using internal clock pulse, right? No problem in it. So C by T is equal to 0, right? And now whenever it use counter, whenever we use an external clock pulse, what we will use, like whenever we use an external clock pulse, it will work as a counter. Clear? Right? Now, to understand this information, now you understand what is TR0, TR1, right? You can see all these things are present in TR0, TR1, and this INTX, all these are present in TMOD and TCON register. So we will see basics about TMOD and TCON register. We will see in depth about little later, but we will see why we use TMOD register, why we use TCON register, right? So you can see this is the TMOD register. As I said, it just tells you, like, we have to configure the different timers, right? In which mode it has to work, whether it works in timer mode or counter mode, or if it is working in mode 0, mode 1, mode 2, mode 3, like that, right? So as of now you understand that you have 3 different modes, that is 4 different modes, which is mode 0, mode 1, mode 2, mode 3, right? I'll explain about these 4 modes in next video. But now you understand what is TMOD register, right? So TMOD register will have M0, M1, right? And now you understand what is C by T and what is gate, right? What is C by T? You understand C by T will be 0, right? When it is used as a timer. C by T is equal to 1 when it is used as a counter, correct? Right. And what is gate bit? Gate bit will be 0 for timer operation, correct? And gate bit will be 1 for counter operation, correct? Right. So that is what given here. You can see here C by T, whenever it is cleared for timer operation, it will be 0 and it will be set for counter operation. And you can see whenever the gate control is set, then definitely we will use this INT pin high, right? That is what I said before, right? Because if gate pin is 1, then definitely INT pin also must be 1, right? Because if gate pin is 1, then it will become 0 and the input will become 0 here. So here what we have to do, we have to definitely give INT pin. If it is cleared, if gate bit is 0, then we don't want to worry about the INT pin X itself, correct? Right? Now you understand when we have to give 0 and 1 for gate, and when it is 0 and when it is 1 for C by T, it tells you whether it works as a timer or a counter, right? And M0 and M1 is nothing but 4 different modes of operation of timers, which we see little later, right? But as if now you understand there is 0, 1, 2, 3 modes, where we will use in mode 0 you will have 13-bit timer, and in mode 1 it will be a 16-bit timer, and in mode 2 it will be 8-bit, and similarly even here in mode 3 you will have 8-bit. You will have split timers, but it will be used in 8-bit. This is about TMOD register, right? And now we will see what is TCON register. I have already said what is TCON register. It controls the timing and operation. You can able to configure TCON register, right? So that we can able to control the timing and control operation, correct? Now this is the TCON register. You can see that in TCON register you have 8 bits D0 to D7, right? And I'll explain one by one here, right? The lower 4 bits, you can see these 4 bits are set for controlling the interrupt bits, right? Controlling the interrupt bits. We will see what is interrupt in depth in next videos, okay? Right. So this thing is about the interrupts, right? And these 4 tells you which timer we are going to use, whether timer 0 or timer 1, right? As I said, you have timer 0 and timer 1. If you use timer 0, right? If you use timer 0, what will happen? TR0. I already said what is TR0. This pin will be 1, right? If this pin is 1, which means we are using timer 0, right? If this pin is 1, then we are using timer 1, right? So either timer 0 or timer 1 will be used. That will be indicated by this 2 bits. What is in operation? Timer 0 or timer 1, right? And similarly, whenever we use this registers, timer registers, right? I already said it's been split into higher bits and lower bits, right? That is 000 lower bits, right? Lower 8 bits and higher 8 bits, correct? Right. So which means it will start from 000 and it will reach up to this particular value, right? And whenever it reaches this particular value FFFF, then it once again roll back to this particular 000, right? Which means an overflow will happen. Every timer, whenever there is a roll off, overflow will happen. So if you are using timer 0 flag, overflow flag will be enabled, right? If you are using timer 1 overflow flag will be enabled. So that is represented here. TF0 represents the overflow flag of timer 0. TF1 represents the overflow flag of timer 1, right? So if you are using timer 0, then this pin will be 1, and when it overflows, this pin will be 1. When this overflows, an interrupt will be given, interrupt will be generated, right? We will see interrupt in next video, right? And similarly, when you are using TR1, right, then it will, if it overflows, then TF1 will be enabled, right? And apart from it, we have seen something called INTX, which is nothing but the external clock pulse which we give, right? External interrupt, right? Whenever the external interrupt, right, that will be enabled in these 2 pins. You can see external interrupt 0 and external interrupt 1, right? IE0 and IE1. It tells you the external interrupt 0 and external interrupt 1, right? And this external interrupt 0 and external interrupt 1, right, it can happen in 2 different methods. That is either a negative edged method, negative edged or level edged, right? So these 2 bits, IT1 and IT0, it tells you how this external interrupt happens, whether it is because of negative edged or level edged. It is set or reset. Clear? This is about TCON register, right? So don't get confused. All you have to understand now is why we use TCON register. TCON register tells you which timer is working, right? How to configure that timer, right? That is which timer is working, TR1 or TR0, which overflow is happening, right? That is timer 0 overflow flag or timer 1 overflow flag. All these things comes under TCON register. Whereas in TMOD register, we can select different modes of operation for both the timers, right? So today what we have seen so far is we have seen basics about the timer and counter operation, right? And we have just saw about TCON register, where I have said about all these pins, right? These pins are bit addressable. So what is meant by bit addressable? We can set that pin and we can reset that pin by using a single instruction. You can see here for timer 0, all this TR0 is related to timer 0. We can set that by set B TR0, which will make TR0 to 1, right? Similarly, we can clear that by using this instruction. We can make TR0 to 0. Similarly, we can make this TF flag, TF0 as 1 by using this instruction, set B. And similarly, we can clear that. And similarly, you can see here for timer 1 also, we can use this instruction to set and use this instruction to clear that, right? And these are the numbers where you can understand when we have to set TF0, then we have to use TCON.5, right? So it is nothing but 0, 1, 2, 3, 4, 5, right? 6, 7. So this is the numbers which are represented here, right? The corresponding bit TCON 0.4, which represents the TR0, and similarly 0.5, TCON 0.5 represents TF0. Similarly, 0.6 represents TR1 and 0.7 represents TF1, right? So today we have seen basics about the timer and counter operation. What are 16-bit timers right? And we have seen when it works as a timer and a counter, and we have seen what is TMOD register and what is TCON register, right? So hope this video is very useful for you. Thank you, my dear students.
Thank you students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.